Hi there, my name is Honor Hugo and I'm a breast cancer researcher. Did you know that 1 in 8 women will be diagnosed with breast cancer in their lifetime, and that 8 women in Australia every day die from breast cancer? And once breast cancer has spread, there is no cure. And the best screening method that we have here in Australia is via mammography. However, for 8% of all women, mammography may not be sensitive in detecting their cancer, because they have something called mammographic density, and it can impair the ability of a radiologist to see the cancer. Here we have a woman with very high breast density, and then here we have a woman with low breast density. And as you can imagine, a woman with high breast density is very hard to see a cancer if it is present. So mammographic density is an issue for masking. It makes it very hard for the radiologist to see a cancer, like trying to spot a polar bear in a snowstorm. But we actually are understanding now that there is more to this tissue, that it creates and promotes fertile soil for tumour growth. Mammographic density is reduced by anti-estrogen therapies. So it may be a biomarker to determine whether a woman is responding to anti-estrogen therapies, and that output can be measured. Not by mammography, because that involves ionising radiation. We certainly don't want to expose the woman who may need frequent monitoring to ionising radiation. What we propose is the NMR mouse. So we see excellent concordance between mammographic density and NMR mouse T1 measures on the same sample. So what we propose to do is to use a modified massage table and place the NMR mouse unit underneath this table, and the woman would lay down face down onto the table and can be fully clothed in light clothing, and then her measures will be taken from underneath the massage table, aiming for the upper outer quadrant of the breast. So what do we want to raise money for specifically? Well, $5,000 would allow us to do some single-cell RNA sequencing done on mammographic density tissue. As we mentioned, we're interested in the biology behind breast cancer risk associated with MD, and we would like to know the specific expression of genes in the various cell types that make up this tissue to better understand it. But ultimately, we would like to raise money to purchase an additional NMR mouse unit so that we can monitor women on tamoxifen therapy in maybe a rural or remote location, so enabling more women to be reached by this novel technology. So the MD team is made up of a medical physicist, Dr. Constantine Marmot. We have a student, Xuan Hung, and myself being a cancer biologist. Rick Thompson is also on the team. Gillian Jargo is a clinical research nurse, and we have the expertise of Tom Lloyd at PA, who's a radiologist. So this work is ongoing support is being provided by the PA Research Foundation, and we thank them for their support.